In this video, we'll start the new chapter, chapter number 4, structure of atoms or structure of atom. Since we know that in the previous chapter, atom is a smallest tiny particles, okay, which is a divisible, which contains subatomic particles, proton, electron, neutron. Okay. In this chapter, we'll discuss that particles only and different theories given by the different scientists about the atoms and its structure. Okay, who discover what? Let us have in this chapter. Okay, so what you mean by charged particle we'll understand in this chapter. Okay, let us have a diagram of an atom. Every atom consists of what? Electron, proton and neutron. Okay, proton and neutron are present at the center of the atom. That center of the atom we are calling what? A nucleus. Okay, and surrounding this atom, this nucleus, electrons are revolving in a specific orbit. Okay, or path of the electrons called orbits. Electrons are discovered by scientist J.J. Thamson. Okay, electrons are what? Subatomic particles. Electrons are subatomic particles having a charge negative. Okay, and their mass is negligible. Charge is negative, mass is negligible. Okay, compared to other masses, subatomic particle masses, the mass of the electrons is negligible, no mass. Okay, now proton is a positive charge particle. Proton is what? Positive charge particle, and they are having a mass. They are having some mass quantity. Okay. Now neutron doesn't having any charge. Neutron doesn't having any charge. Zero charge they are having. No positive, no negative. They are having a zero charge, no charge. Okay, zero charge. Okay, but they are having a mass. Okay. So electron discovered by J.J. Thomson, proton discovered by E. Goldstein, and the neutron discovered by C. Chadwick. Okay. Now this canal rays nothing but see here, canal rays are positively charged radiation, or we say the group of protons when they are moving, we are calling that group of protons as a canal rays. Okay. So what is canal rays? Positive charge radiation of the atom. Okay. Okay, that is group of protons moving. That group of protons are called what? Canal rays. Now let us have the first theory, atomic theory given by the J.J. Thomson about the atom. Okay. According to his theory, an atom, the whole atom is a positively charged sphere. Okay, what the first point about the J.J. Thomson model of an atom? The whole complete atom is a complete sphere which is showing a charge. What type of charge? Positive charge. Okay. And the second point he given that this sphere, positive charge sphere, is embedded with a negatively charged particles. These negatively charged particles shown here, these are called electrons. Okay, according to whose theory? J.J. Thomson theory. And one more here, according to his theory, that this whole atom is a neutral, means whatever magnitude of positive sphere is there, same magnitude of this negative embedded electrons. Hence the complete atom is a neutral. So 3 points or 3 postulates we are having about the Thomson model of an atom. So what is that? The whole atom is a positive sphere. Okay, and electrons are embedded, fixed. Okay, and the third point is the complete atom is an isolated atom. That a neutral atom means no charge at all, because whatever magnitude of the electrons are there, same magnitude is there for this positive complete sphere. Hence the charge will be 0. This atom showing 0 charge. Okay. Next theory is Rutherford model of an atom. he done one experiment. What the experiment is done is he took one gold foil, ठीक है, okay, gold thin sheet, and on that thin sheet he passes what alpha particles. Alpha particles in the sense protons only. The flow of the proton or the helium atom, charge of helium atoms. When he passes into that gold foil, he observed some points here. What the points we'll discuss. Okay. What is the experiment? He took a thin sheet and passes a alpha particle, that is a helium charged particles. Okay. And he observed 3 points here. What are the 3 points? First point, most of the fast moving alpha particles passed straight through the gold foil. Okay. Whatever alpha particles are there, maximum alpha particles are passing through the sheets. They are not bouncing back. They are not reflecting. Okay. Most of the alpha particles moving through the gold foil. Second observation he had, some of the alpha particles were deflected by the foil. Okay, some only see here, some are deflected, some are alpha particles are deflected. Okay, when the alpha particles will get deflect, or when the any matter or a material or any radiation get deflect, when they bounce back, then only get deflect. Why they will bounce back? Because of the when they are striking to some material or some mass, then only they get deflect. So hence here the some alpha particles, when hitting to the center part of the nucleus, this center part of the this atoms of this foils of gold foils, they will deflect. Okay. And few particles are rebound. Few particles are rebound. Rebound in the sense, whatever direction they fall on the sheet, in the same direction they get a deflect. Okay. That is a rebound. Observe here. This line, these lines. Okay. These lines are passing here, rebound. They will gone and comes back. Okay. They will hit here. They will hit and bounce back. Okay. What it means? The atom concentrating its mass, a very small mass, only at the center. When the alpha particles strike on the center or the nucleus, where we are having mass of a proton and a neutron, that alpha particle get bounced back. Okay. So only a small section of mass is present in the atom. Hence we are observing what here, a few radiation of few alpha particles or get a rebound in the same direction. Okay. Bounce back in the same direction, rebound in the same direction. Okay. So 3 observation we had here. What are the 3 observation? The first observation is most of the alpha particle passing through the foil, and a few are what some are what get deflected, making an angle, and very few are get deflected in the same direction, rebound. Okay. After the observation, he concluded the 3 points here. What the conclusion here? Most of the space inside the atom is empty. Inside the atom, most of the space is empty, khulla space. Okay. Hence these radiations are passing. Okay. And very few particles are deflected from their path. What it means? Due to the positive sphere, this positive nucleus, the alpha particles get deflects, and very small fractions are rebound. Okay, means coming back or bounce back in the same direction, because the mass of the atom is concentrated into center. It's a very small. Therefore, we are having a few alpha particles get deflected in the same direction or rebound in the same direction. That is the conclusion of the Rutherford theory. Okay. After this his theory, he given 3 postulates here, points here. Okay. What their point is? According to this Rutherford postulates, there is a positively charged center in an atom called the nucleus. He discovered the nucleus. What, according to him, the whole mass of the atom is concentrated at the center. That center containing proton and neutron. Okay. That center is called a nucleus, having a mass. Okay. The electrons revolve around the nucleus, and according to his theory, the electrons are revolving around the nucleus in a specific path. Electrons are revolving, ठीक है, in a path. The size of the nucleus is very small as compared to the size of the atom. Yes, of course. This is size of the atom, this is size of the nucleus. By comparing the size of the atom, the nucleus size is a very small. ठीक है, this is the postulate given by the Rutherford.